the iterations which execute over a given interval of time, or like something an specified condition is given or not, right? So we saw that we have some two kind of loops, particularly kind as while loops and for loops, right? And we saw that the while statement is having some particular sets, like it has while keyword, it has a condition, it has a column, it has some indented blocks, which is called as your while clause, right? So the syntax is like you write the while expression and then you write the body of the while. Sorry. So I'm just printing as the sum of the first 10 numbers, right? So I've just taken n equals to 10 and my sum is 1 plus and so on till 10 I'm taking outward. And I've taken my counter, this x, as my counter. So my counter is my 1, my sum is my 0, and I've taken that while my x is less than equals to 10, that is until and unless my x becomes 10, I'll be just adding on the values of the x to the sum and then we'll store in the sum, right? And then I've just printed down there and it's came like sum equals to 1, so first x equals to 1, sum is equals to 1. X equals to 2, sum is equals to sum plus 1, that is 2. X equals 3, sum 3, and 4, 5. And similarly, we have rest till since x equals to 11, as soon as x becomes 11, they will just come out. We'll check this condition, it's wrong, and we'll come out of the loop, right? So this has been done here. All right. Next we saw that we have a range that is particularly syntax as start, stop, and step of the interval, or you can say step is nothing but the intervals. So if you write a range of some particular number, it will by default it will take it starting from the 0, and we'll have the list of numbers. If you write print it on, so you have list of numbers till the 19. Similarly, if I take a list of range of numbers from some given range, like for 5 or 17, I'll be getting it from there, right? Uh, like that, I have just taken a range of 0 to 50, and there I have taken the numbers in the intervals of the 3. So you will be getting the numbers in the interval of the 3. Okay, then we move to the for loop, and again in the same case as we did in the while one, we just took a list of numbers as 1 to 10 over there, and then we took a sum that is equals to 0. And now I have just mentioned a variable kind of iterations. So for iterations in the numbers, it will just keep on adding all the numbers, the number of elements it is having in the particular list, right? So this is how this is how you just work with a for loop, right? So this sum of iterations, so as soon as my iteration is 1, my sum is 1. My iteration is 2, or you can say the element is 2, your sum is 3, and iterations are 3, your sum is 6, and so on, right? So as soon as your iteration becomes 10, the elements is no more there in the list, so your sum becomes 55, all right? And this is how you just get it. So we then saw the strings method, something, not the whole, we just saw a little today, we'll continue tomorrow with the strings in the morning. So we just saw the strings are the characters which are surrounded by a single or a double quotes, right? And right, as like we have the not of true, so not of true is something as false, not of some student were having doubt in this section. Similarly, we just go to see how can we just write on a multi-string. So a string is just you use 3 quotes over there to just write down a multi-string there, right? So these are just of the very common things. Then you use slash n to just print a multi-string. You can just use slash n is used as far as for the multi-string. Suppose we see the ASCII codes, we compare it with the ORT, right? So I've taken a capital and I have split it there. So I have got a list of all the capital things. And similarly, I just took off all the lower one and done for the lower two. Alright, so I have the capitals, I have the lower ones with me now as a kind of AC capital. So capital is having a list of capital letters, and the lowers is having a list of lower numbers, lower letters, right? So lowercase. So now I'm just printing that the 4 codes in the capital. Just print ASCII value of the SS is codes and all. That is ASCII value of some individual numbers would be like that. So it is ASCII code of A 65, B 66, and so on. It goes till the Z, it's 90. Similarly, for the lower ones, we get with all these things. So you have a proper video of this session. You'll be getting it, understanding that well. Okay. Suppose we just started for the indexing session. Once again, we just went up to see the indexing, and there we saw like the first element itself starts from the 0 and it continues till then the 1 2 3 and then whatever the length minus 1. Okay, so indexing always starts from 0 and will go always to the length of the it's just the kind of, let's say, any particular uh, variable you have. The indexing will start from the 0 and it will go to the length of the variable minus 1. So always your range would be kind of this. Okay, so it will always go to the length of the variable minus 1. That is, if I am having length of my variable as 23, so my last index value would be 22. Understood? So if I just print on st of 22, I'll be getting it there. See, my last is a dot. Understood? So these are the things to be focused on. 0 to n minus 1. I didn't get what you're asking. Yep, n could be our number of digits or characters in your particular variable, and then you can just you can do that, n 0 to n minus 1, correct, right? So n of 0 to n minus 1. Okay, so these are just the ranges, basic things. Okay, you can get it there. And we have studied the concatenation, replication, so not going again. Okay, then we just come up with the sum of the string methods, like we use the strip. So that is basically used to remove the white space from the beginning of a code. So we took that Amazon having some spaces over there, we printed off, we saw the Amazon basic, Amazon the natural, we write it a printing, so you're getting like that. If you use strip, you'll just, the white spaces will be removed. Similarly for the lower, we just take, we saw that it returns a string copy which is converted into a lowercase. So then we just took off for the case fold, and that too also returns a thing to the lowercase. Okay, so similarly we just find the str help and just we can take everything from the there, right? Same as we just took for the capitalize and replace everything, we just get to understand there. Okay, I'm not getting much into the deep of all these. Yeah, this one is good for you. We just you can say work on the Google search code, a very short code. We just try to search from the Google search, import the search, and then accept the imports error, and then we just search down for the things. Okay, so there we did just for the basic of the things, right? Just like we search on for any particular topic. Let's say you are searching for the Google Assistant. So it's type of an assistant for you, right? You will just ask anything and it will be giving you the search results basing on the number of search you want. The stop is specified for the, if you want to just stop after some point of the search. So these are the things. Okay, so these were the basic guys you will be seeing in the morning video. Okay, so let's start with our one. So yesterday we dealt with the SymPy and a lot of we have that. Okay, yes. So yesterday, suddenly just in the evening, my brother just asked me a question. That his question was like, there is a rectangle, right? And it was said that the diagonal is the greater than 60, right? The diagonal is greater than the, or it was something like, what was written? Okay, there was a rectangle, right? There was a rectangle, and it was said. So the keywords were, so there was a rectangle, and it was said that there is a shortest side. All right, obviously it has, and there is a longest side. So it says that the longest side is greater than the shorter side by the 30. So the longest side is like uh, shortest plus the, I think it was 60. It was 60, I think, right? For 60, and the diagonal was something supposed to be, diagonal was supposed to be the shortest side plus the 30. So it was fine. It was just used to find the shortest side. So the equations was like that. If I just make it, it was something like x, and then you have the longest side as x plus 60, and then you have the shortest side plus x plus 30. And now you guys, now let me just tell me how will I get the x using these things. What is a very basic thing I will using. Uh, I just made a couple of codes and just tell in the answer there. So yes, expecting answers from you guys. You have to bring the Yahoo and all these things, libraries of that. What does pause do? So particularly your pause, Pooja, your pause will just give you the number of iterations you are just working on there. So you'll be just, if you just see, if I just remove this pause, okay, you're asking for the pause, sorry. So pause will just keep on iterating from the HTTPS. You are coming with the search with the Google, right? So if you give a less pause, that will be a IP problem. That is an IP issue will be there. So you just give it probably like above 2 or above 1.5. That particularly defines you that you can say that particularly defines the number of searches or number of interactions you are just doing with the domain, your particular domain. Okay, so that is got any right. Fine. So anyone giving the answer of this particular question? I have one rectangle where I have diagonal that is x plus 30, and the longest side I think it's x plus 60. X into x plus 30 is equals to, once again, what I did. Once again, it was x. Yes, these were the three parameters, right? So find the x. Anyone? What will be my x values? Basic, yeah. This is a kind of a rectangle, right? Yeah, so yeah, x plus 30 square equals to, Harita is giving, probably it was kind of x plus 30 square, or it was x plus 60. It was x plus 30 plus x equals to x plus 60, right? So it was a kind of an equation where I have to write it as uh, just like the equation would be something like it was x square plus x plus 30 square, and this was my left hand side particularly. Similarly, I have a right hand side which is an equals to x minus, sorry, x plus 60. So yes, this was an equation. So I come up with an expression that is your x square plus, just copy paste this. So this is just a practical implications of how you can apply this. I came up with it just as this is equals to be this. Exactly, right? So this will be equals to the 0 exactly. Yes, any answers from these things? Yeah, okay. So this is an expression that is okay, fine. Right, so x is not defined, that is correct. So yes, now the error is coming, x is not defined. So what should I do there? Yes, any answers from this? Yeah, and Pooja's answer, right? So pause basically will define for the lapse to wait between the HTTP request if you go for the standard definition of those. Okay, so if you keep the lapse very short, it may just cause Google to block your IP. That was what I'm saying. Okay, so lapse will just give you the wait time, that is how much time you are just waiting, 1 second, 2 second to come with the results. Okay, that is the pause. Yeah, what should I do to just print or to find out the x? So this is my equation. I'm saying now this is my where it is. This is my equation, that is x square plus the x plus 30 whole square minus x plus 60 whole square. Now what should I do? Yes, guys, you read the SymPy yesterday. Now I think you must have practiced. Here's answers from you. What is the what is the very first thing I have to write here before writing all these things? What are the very first things which I should write? I have imported SymPy, right? So now what are the things I have to mention here? See, unless you just practice on the things, that will be just kind of a messy. Okay, and this will create some burdens, and at last you will think of that we just went to a training and didn't learn anything. Just we had a look over the things, not learned. Okay, so to write the exp symbols exactly, so you have to write the symbols. So first define the x as the oh no, that is not okay. It's fine. So first I have defined my x to be the symbol, and then if I may see my expression, that is an x square plus x plus 30 square minus x minus 60 square, and that is an exactly right. So what are my answer? How to find the answer now?
So we can use a square minus b square 1.
This is x plus 60, this is x plus 30. A single step to give your answer. What is that? Try. Anyone there? Simplify. Anusha is saying for simplify. Okay, we'll try. Let me count the only simply. Meanwhile, any much answers there? No. Everyone is stuck in the simplify. Any other answers? So it's x square minus 60x minus 2700. All right. Yeah, just fine. So this is my simplified answer. All right. So my simplified answer, guys, are x square minus 660x minus 2700. Now factorize. All right. So my answer would be x minus 90 and x plus 30. So can side be in the negative one? So the answer would be yes, minus 90 and plus 30. What will be the answer? The factorize solve method.
90.
So you see, you can just perform on the basic mathematics calculations. Right? If I would have written it, factor of the equation. Sorry. So I would have got it there only instead of doing simplify. But that was what I'm saying, because you have the libraries and you have the functions. You don't need to simplify and then search on all these things. Okay. So Anusha, you can directly get it from the factorize method. Okay. You don't need to simplify and do all those things, right? You can directly write your equation and then you can just factorize to get the answers. So these are the simple things, right? You can work there, right? So moving ahead. So we dealt with the, I think yesterday we did up to cancel, I think, right? So let's take an expression. We'll sum up today the simple one. Complete this one today. And tomorrow I'll just take a small test of this simpy. Alright? Because this is an important module to learn on. So tomorrow you'll be having a small test. Right? So practice is today. Today have a good practice on simpy. Let's take it like have an expression one. It should be the symbols. So let my symbols would be alright. So again, symbols are not specified. Why is this coming errors? I don't know. So x and y are my symbols, that is x and the y. Now let me close this one. Now what I'm doing is I'm just writing down an equation. Let it be any particular equation. Let it be ex1, which would be kind of x plus y. Arabic is not callable.
So there will be comma in the parameter sp dot symbols.
We'll take x plus y. Symbols are having comma. It's not required, kind of, because that is good to. Without the commas, also we can write it there. We did it, I think, yesterday. We did it the symbols without the commas. it is not necessary to write down the commas in the symbols. Still, let's see. So let the equation would be ex1. If I see ex1, what is it? It's 2. Okay. Yeah, obviously it would be a 2x idea. So let there be any particular expression, and I just want to cancel it out. It would be kind of let's take any answer. Let's divide it by okay, 3y minus 2 by y minus 4 and plus 1 by y. This is now the equation. So this is what if I want to just cancel on this equation. So yesterday we did with all these things, right? We did it all the things yesterday as kind of a coming inside the there, that is from the SymPy we imported the star, and there it is an error, that all. So cancel of ex. So your cancel is of kind of your 3y square minus 2y square minus 8, and by 2y square minus of all these. So let's see if we can factorize these things. So yes, we can factorize it by y minus 2, 3y minus 4, and then 2y, y minus 4.
Sir, in cell number 25, what is that from SymPy import star, that star one? This star
That is all the
one.
modules you are importing on. So instead of writing for sp dot factor or every time sp dot all these, I'll be just writing out that factor or cancel on this. Okay, I don't need to write
Oh,
the sp or smp a lot of time for that.
okay, sir.
Now let's see some trigonometric identities. So yesterday we started up to the trigonometric ones. So this particularly function is used to simplify the trigonometric identities. Okay, and it may be like for the naming conventions of the inverse trigonometric functions, to append anything in the function name, right? So like for the cosine, or you can say a cosine, a sine, a tan, and so on, right? So particularly what you say, it is for simplifying trigonometric identities. All right, that's all. All right, so this is just for that purpose. So there we write from the SymPy, we need to import all the trigonometric simplifiers, and you can just write any particular thing. Let's say we want to find the sine, and we also the tan, also the cot, also the cos, and all these things. Alright, so we have imported these things now. And also I'll importing the from simpy.abc. Remember what these things are? We have alphabets over there. So practice today these things, because we will having a test tomorrow, and I'll be giving linear equation questions tomorrow. Okay, so you'll be getting just a kind of word problems, and then make it into a mathematics and solve it with the programming. Okay. You solve it. You have solved everything with the pen, right? You are smart enough to solve the questions with the pen. But when it comes to the coding section, that would be a problematic situation for many ones. Okay, so make a habit for solving all these things. So my brother was just doing the factorization, and I just wrote a couple of codes, and I said, "This is the answer." He said, "What is this doing? I can't sit in the examination with this laptop." So okay, so from simpy.abc, just import x, y, and z. Well, it depends. Let's import the theta, gamma, and delta. Okay. Now let's take an expression. Let it be expression 1 and indicates all. Yes. So from this, I'll just make down an expression that is my. Let's say, guys, if I write a sine theta squared, right? Now just let us do some of the trigonometric equations. Okay, so I'll be giving you the questions, and do you all are doing the coding with me now? All are just doing the coding with me. Anyone who is not doing, might be the case that most of you would not be doing. Still, how many of you are doing with me? I will be giving you some questions then. How many are there? No one. Okay, everyone is just seeing over there. Yukta is doing alright. Fine. Pooja is doing. Harita is doing. Vams is doing. Alright, I can see 4, 5. That's enough. Okay, fine. No problem. So we'll doing class 10 mathematic questions, right? Basic identities and factorizations, so that you have a practice on that. So let's say we have 2 into sine squared, the basic thing, 2 into sine squared cos squared theta, and then just write down at a kind of similarly for the cos. So yes, what is the value of this particular line? Yes, just see and tell, and don't need to calculate. What is the value? Your time has been passed. You should see within
2.
some. The Adarsh is saying 2. All
2.
right. And what about all next? Tomorrow, what will happen? See, I'll show you a question only for just 10 seconds. That's all. And you have to memorize the particular equation in the 10 seconds, and you have to answer that. So, meanwhile, I'll be training you like for an interviewer, okay, so that you can have a good experience in the training. All right. So, it is necessary just to cos 2x, Sneha is giving, all right. Again, I am showing you. Keep your eyes on the screen, and it will be just shown for the 3 seconds, okay, only for the 3 seconds. Now I'm showing you, right? See, 1, oh sorry, 1, 2, 3. That's all. Answer.
2.
Adarsh answer is still 2. Anusha is 2. Rohit 2. Alright, fine. That's easy. That's an easy statement, right? That is your sine theta square plus cos theta square, and multiplying it by 2 will definitely give you an output result of. There is some problem once again. There's something I have written wrong. This I have written wrong. This. Again, this is sine squared theta plus cos squared theta. That's fine. And the 2 is common from both the sides, yes. So that will be probably 2. Exactly, your answer is correct. Okay, so there is some just writing problem. Okay, if I just write it kind of this. So this is particularly. Yeah, good. So this is multiplied by 2 exactly, and nothing else. So you'll be getting an answer. Your 2 is the correct answer. That's not wrong. Okay, this is 2 is the answer. So you can write it like 2 multiplied by sine theta square and plus your cos theta square, and that is correct. Okay, so what we'll have to do, see, So 2 is the answer, but still we are getting ex1 as our 2 sine squared theta plus cos squared theta, right? And what I mean to say is, why I'm using this function, you will be seeing that that answer is correct, right? This will be, if I just put over a bracket over that is the correct answer. But I'm getting it again as a 2 sine squared theta plus cos squared theta. So what I'll doing here is I'll just pass on the function that is your trig. Let me write as trig. Okay, trig is, and that's your function. And then you pass on your expression value. And now you can see your the answer is wrong. 1 second. Hello? I'm in class, call you later. क्लास में हूँ, बाद में बात करता हूँ. Alright, so there is some problems I still see. What is the problem, guys? Can you see it there? Cos squared theta. Okay, okay. Let's make it there, like, kind of. Yeah, got it. Brackets, correct. So bracket was an error. Okay, fine. So similarly, these things are just kind of, let me give you an equation now. You just solve it there. Okay, using your codes. Okay, don't just go for just applying factorize and then solve it. No. Alright. So my question is very easy. A very easy question. Alright. So I'm just writing that if, okay, I'm just sitting with Adi Sharma in front of me now. So I'll be giving you just good questions out. So let's think of that sec theta. Oh, I haven't imported the sec one. So let's take it off. Okay, I'll import there, no worry. So let's take that sec theta and tan theta is equals to P. So don't give the answers by just calculating, guys. I know you guys are much smarter there. It doesn't do it by coding. Okay. So obtain the values of a lot of you would have practiced trigonometry in class 10 or class 11, right? And still might of you will be doing now. Some of you will. So find the values of the sec theta, the tan theta, and the sin theta in terms of P. Yes, that's a good question. Okay, so you will be getting some 5 minutes, that's all, right? Think of and just write down the answers. You can do one thing, you can just solve with this with the pen and paper in your copy and then try the logic to bring it there in the code. Okay, this is the random question which I saw. I just opened the RD Sharma, I just saw the book and I just gave a random question to you guys. I'm also solving now. Okay, so yes, start solving. Let me also solve. And let it be LHS. RHS1 is P and LHS1 is this. LHS1 P, and what is the value of P? Alright, so we have LHS1 correct. Now I know that sec theta square minus the tan theta square minus 1 is equals to 0. So this is my expression 2. How many are solving? 1 by P. Whose value is 1 by P? Vamsi Krishna, what are the codes they have applied? Pen and copy, right? 1 by P will be getting there. 1 by P. So what is the value of, I ask you for the values of sine theta, sec theta and tan theta. Yes. Okay, so this is my expression 2. If I see my expression 2, it would be likely to be minus tan square theta plus x square theta minus 1. Exactly correct. That gives me that sec is theta. That states that sec theta plus tan theta multiplied by that could be an expression 3. So sec theta plus tan theta into the sec theta minus tan theta. One. Correct. So the value of this is 1. Alright. Still doing. Do. That's good. You should do. Alright. So if we multiply.
Can you slow down a question, please?
Question. Okay. See.
Yes, sir.
Alright.
I have found for sec theta minus tan theta, so only I got 1 by.
No, I thought of that. That's good. So sec theta minus tan theta is probably p multiplied by this. No. So this value will be equals to, this will be equals exactly to the 1 by p.
Yes, sir. This I got it.
You got this, right? So
Yes,
sec theta minus, this is what you got. I can't assign to the operator. Yes, exactly, that is correct. So you got this as the value of 1 by p, right? So this is my expression 4, and I see my expression 4. It's kind of sec theta minus tan theta, and this ex4 is equals to RHS1. That is sec theta minus tan theta is equals to, yes, so obviously sec theta minus tan theta is equals to 1 by p. That is, so similarly you can just apply the methods of sec theta plus tan theta minus sec theta minus tan theta. So if sec theta plus tan theta is equals to p, so let x be sec theta minus tan theta. Let now x be as your sec theta plus your tan theta. Alright, so if my x is sec theta plus tan theta, and similarly let my y, anyone have solved? Please explain the codes. No, I didn't explain till now, Pooja. You just keep on trying. I'm also trying now. Sec theta minus tan theta. So this is probably my y. So my y is sec theta minus tan theta. Alright. So if I see my x comma y, I have values tan theta plus sec theta and tan theta minus sec theta. Alright, correct. Okay. Now these, if I minus this x minus y, so I'll get 2 tan theta, right? Correct. Okay.
If multiply, you get 1 by p, no, sir?
Yeah.
X, y.
If you multiply it, you'll be getting value if you multiply it, you will be getting 1, right? So x, y, this is the value of x, y. Yeah. X, y is equals to 1, and x minus y is...
Yes, sir. But if we want in p terms, then we need to equal this, sir. Equal to p, then we will get 1 by p.
Yes. So your sec theta plus tan theta is also equals to p, right?
Yes, sir.
So let me write it here. That is your x, which is x my, where is my x sec theta plus tan theta? So x is also equals to p, and y is, that is my sec theta minus tan theta, that is also equals to 1 by p. If I see my x and y, those are p and 1 by p, right? So when we equate this to like kind of 2 sec theta, that will be equals to x, that will be equals to x plus y, right? 2 sec theta, we got it here, right? That is your this 2 tan theta will be in the minus term, and sec theta, 2 sec theta will be in the plus term. Similarly, when we apply that 2 sec theta, invalid syntax there, 2 sec theta will be equals to the x plus y, right? So let these x plus y, let's add first. Let's see what x plus y gives. So it gives you p plus 1 by p, right? So let's assign x plus y as s, right? So this s is now your p plus 1 by p. So you assign your s to be equals as, or you just say that 2 multiplied by sec theta is equals to your s, right? That is 2 sec theta, which is equals to p plus 1 by p. Okay, so from there you get a relation, can't assign to operator, why? Okay, so from there you get a relation that 2 sec theta is equals to p plus 1 by p. So keep on solving that now. How you keep to solve that? Now that is your left hand side and that is your right hand side. We came with the solution of this and this. So from there, can we get the sec theta value? Similarly, you will be getting in the tan theta also. Tan theta you will be getting half of p minus 1 by p. Alright. So if you go on solving this, so anyone is listening on being confusing, guys? Anyone is getting confused? These are basic mathematics. Just here, what we have to do is we have to assign the individual variables to solve on, right? So you just make the solution first in your copy, and then you just come up only with the last codes and just apply the last codes over there. That is okay. So my last codes would be, if I just go on finding for the sine theta. So my last codes will be kind of, that is it. It is just like p square minus 1 divided by the p square plus 1. So it was kind of this, right? So when you come with this solution, your sine theta would probably be equals to with this equation, right? So you can't assign to the function, that's no worry. Okay, so you can write your x, or it would be s. No, s has been assigned, right? So r and the f. So your r would be the sine theta, which is equals to the p square minus 1 by p square minus 1 by p square plus 1. This is your final, like for the sine theta will be this, right? And the sec theta would be just half of p plus 1 by p, and tan theta would be half of p minus 1 by p. So these are the things you would be doing on, right? This is how you will be solving on the things to make it just right. Okay, so these are the things you should just work with the things. Okay, you do one thing. You might have your class 8, 9, 10th book with you of the R.D. Sharma or like that. Okay, so do one thing. Just go on finding the values and just keep on solving the equations. So you'll be getting a habit of just doing mathematics there. Okay, so let's say now your kind of your sec theta plus your tan theta is equals to some value. That would be equals to some of the value. Let's say it's equals to p, right? So now you have to just show on that this particular value, this is p square minus 1. You have to show that the f is equals to sine theta. So then what to write there? So there will write that will bring this one particular f, right? How? We'll write that we know that sec theta or plus the tan theta and the square of these. So we know that the sec square theta plus the tan square, or let be the whole square of them. So this whole square minus 1 would be equals to p square minus 1. If it is said that sec theta plus tan theta is equals to p, then we can write that sec theta plus tan square theta whole square equals to p square minus 1. If I write p square, that is your sec theta plus tan theta whole square, and then minus 1 is this minus 1. That's exactly right. So p square minus 1 is this. Understood? So just make think, right, practically. So p square minus 1 is this minus 1, right? Similarly, when I run this, you'll be getting like that. Similarly, we can run it with the plus 1 also. This kind of do plus. So you'll be getting this equation. Now this is your p square minus 1 and this is your p square plus 1. Exactly. Correct? Now you need to just separate them. So if you separate them, what will come? If you just make a factorization of all these things, you just simplify these things. So what will come there out? So let's pass on this. So you'll see, okay, by passing still we are getting like that. So our equation is this whole divided by this whole. So this is our equation. That is p square minus 1 and p square plus 1 now. Alright. So now you need to solve these. So how you solve this? That tan square theta plus square theta minus 1. That is your tan square theta plus sec square theta plus, yes, right? Just keep on solving, keep on solving. Let's see who solves first. So this is your equation. That is your tan theta square plus sec theta square plus 2 tan theta sec theta minus 1. Exactly. Similarly, this will be the equation when we just you can see this is the particular term you will be getting out. Similarly, you will be getting there in the below one, that is the same things but only the difference of the minus, and here the plus. So this is the equation when we just go with the second line, that is tan square theta plus 2 tan theta sec theta plus sec square theta minus 1 and so on, right? So you get it like that, right? So from here, if we just factorize the things, if we just see on the things what are the common from here, what we can take the common things. Yes guys, what we can take it from here, sec theta can be taken as a common one, right? We can take the common from there, so we can write it like sec square minus 1, and then we can write like kind of, I think, tan, and that would be a square plus your 2 sec think it of if you have been solving it with the basic pen and copy, right? How do you solve? Exactly in the same procedures now we are going, right? So 2 into sec theta into the tan theta. So this is this will be coming as this will be coming as my common, and not the common, just I separate it there, right? And then I'll write tan square theta plus 2 tan theta sec theta there, okay? And this will be divided by the value. This will be coming inside the whole one, and then come with the next one, that is your in the second one. What you can do, if you see the second one question here, second type kind of, yeah, so you can see now. So that would be sec square theta plus your 2 multiplied by sec theta multiplied by the tan theta, right? And what is left there, 1 plus tan square theta. So if you run this, there is some function class unaborted. There is some problems, I think. There is some this type of issue. Correct. 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 This is one bracket, this is the another bracket, come in there, and this is the third bracket, exactly. This is one other term, this is the second other term. Where is the problem? Okay, let me remove all the brackets from there. Yeah. I want these to be one term. No, not exactly like that. Sec square theta minus 1 would be 1 aside, and then tan square theta plus cos square theta. That's fine. So yes, that would be probably getting me to these values, right? Similarly, I'll be having D, and then I'll be pasting on these values. So from, yeah, there was a problem. Where is the issue? There is 2. All right, this was a problem. No one said here the problem. What? For CD, D would be 2 sine theta plus 1 theta. No, wrong. Something is wrong there. Let's just plot this one. Sec square theta plus 1 1 plus tan square theta. That's correct. And yes, that is correct. All right. So you get C as 2 tan squared and these values, and similarly you got D as, okay, that is correct. So D is be equals to Triggs imp of your these values, and this is your D. Right, correct. Now you got your C and D, and you need to divide it by that. And this is your result. That is, you divide this, and when you solve, you will get kind of sine theta, right? So you got sine theta, and what was your RHS? When you look over to the RHS, your RHS was p square 1 minus sine square s, which was given as the sine theta. So you got to see, right, guys? That is your sine theta, p square, this as your value. That was f was equals to r, p square 1 minus 1 and p square plus 1 was, and we got LHS equals to RHS. So did you saw, guys, how we just do the calculations? Was it a mess kind? Yes, anyone? There understood? Let me ask you personally there. What about Surya, Prem, Yukta, Anusha, Harita, Adarsh, Puspa, Pooja, Supriya? Yes, Pooja was having yesterday confusion, sir. Can we just use a kind of a string, or we can just do with the calculations? So I think, Pooja, you would be seeing now that we can do a lot of calculations with these things. Okay, fine. So just the basic things, right, you do in your mathematics portion. Okay, similarly, we'll be doing for the calculus also. Yes, sir, needs to brushed up again, obviously. So these are the things when you solve, right? You will be writing is correctly, like if this is the first statement, then the second statement, then you write like this. Then you come with this statement and this all, and then you, instead of solving and dividing all these, canceling out all these, what I did is just pass out the function, and I got to see that it's sine theta. That's all. I don't need to solve it there, right? So these are just the. What about, yes, Samsi?
So can you please go to the code?
Where these codes to put here?
No. Can you please just open one doubt over there?
Okay, yes.
Sir, here, why you are using Tricks if again?
Where?
117.
117. Okay.
Yeah.
See, if I not use, I am getting it like once again.
Yeah, I'm getting different one.
Yes, right. So this
Yes,
function is particularly used to simplify the trigonometric identities. Okay.
Okay, sir.
So that's why I have used, so that I can just simplify this and come with a very simplified version, that is this one, instead of getting all these. Okay, and then I just cancel out this using again a simplified method. Yes.
Sir, whenever we use
trigonometric identities like sine, tan, or cot, whatever, we need to import it every time when we use from SymPy?
No, once you have imported, you don't need to import it again.
Okay, sir.
Like if you are doing with the trigonometric one, you do one thing, you just go there and in the starting only, you just click from the SymPy import uh, TrigsMP and then your sine, the cot, the tan, the cosec, the, what are the rest? The cos,
Okay,
the sec. What is left there? Sine, cos. I think 1, 2, 3, 4, 5, 6. Correct. So you just import everything there. Okay, there is some problem. Which one is the problem? Users cosec is not imported. All right, fine. So there might be some different name. I think it's cos. So it's like cosine transfer or cos h. This is kind of okay. So there are a lot of things. You just once in just import all these things, and you need not to just work on again and again. Okay. So these are the things, and tomorrow I will be taking your test like this only. Okay. Sir, we can evaluate function like this for basic mathematics in consideration to, like, is it for the basic mathematics? No, you can evaluate functions too. Yeah, move right. Okay. Which question you want to solve, right? Give the question. We will solve it here. We'll just write down the parameters and we'll
Yes,
solve it.
sir. So the trigonometric identities we're solving with the Triggs AMT. So, like, what is the case of evaluation function? When do we use the evaluate function? I just wanted to know that.
Evaluate function.
Yeah.
Did we did the evaluate yesterday?
So some days before we did that, I guess.
Okay. That we do for the complex numbers.
Okay, sir. Okay, sir. Thank you.
Well, okay. So this was a kind of like how just trigonometric one particular thing, right? Similarly, there are a lot of just code there, right? So similarly, if I write TRI, and you can see there are a lot of things, trigonometric and every particular things, right? So from there also, if you want something, you'll be getting it there, right? So if you write trigonometry dot, so you can see there cos, sin, pi, sine, trigonometry dot sine, and then you can write up 60 and any particular thing. So sine of a 60-degree plus your sine of 30-degree and all these. So I can give you a question with that respect also, but not now. Okay, moving ahead. So this will take much time. Moving ahead. So similarly, we saw yesterday that we are also having a function called as parsimp. That is like we have TrigsEmp, we also have parsimp there. That is power is power. That is not exactly power. Is IMP. All right. So this will now give you, I think we did yesterday, might be. So this function will reduce the expression by combining the powers with the similar braces and all these things. Yes, we did it, I remember. We did yesterday, right? Similarly, we just also did for the factorial one also, right? See how the factorial just come break down the factorials of kind of things, right? So we did kind like of factorial. I did it as a factorial I'm sure I'll send something. Manual working SymPy trigonometries. So let's just do one thing. Let's take a factorial and take it at x divided by a factorial of it would be x minus 10 . and let it print. So p okay, x is equals to p. All right. So my x is equals to p. So p factorial by p minus 1. So that would be 10. So p factorial by p minus 10 factorial. Yes. So yesterday we did it that this function was used to combine the combinatorial you can say expressions, right? So that is my this is an e, let's say. Very good. So this is the value, right? This is the just the I can say simplification of all these. We can get it to be. So similarly, we have binomial function which gives a number of ways to choose the y items from a distinct set of the x items. Like if I write for the binomial, so like that will give you the x divided by 1 by p. So these are ways particularly. Right. Okay. So now
Excuse
we'll
me, sir.
yes.
Sir, in that cell number 30, every time e equal to factorial x by factorial x minus 10. Then when we are printing e, so we are getting p factorial by p minus 10. Why in
Because
place of
somewhere
x we
might
are
I have
getting
used x equals to p. Somewhere I would have defined x is equals to p, and where I have defined, let's see.
It went down, sir.
down, sir, down, sir.
See 75.
Yes, sir.
So that's why it is coming there.
Okay, okay.
All right. And now let's see the logs combined. So let's see fast. Today we have to end up with this, and there are a lot of things to do still. Mathematics is kind of thing which takes a good interest, alright. So logs combine takes logarithms and combines them using some rules. What are the rules? Log of x plus log of y. What is the value of that? Log of x into y, right? If both x and y are positive only. What is the value of a into log of x? Okay, a is not defined. That's right. That's a x y into. So what is y into log of x? What is the value? That is exactly it is saying right kind of this thing. So a or y into log of x will give you log of x multiplied or log of x to the power of a, you can say. Okay, so that is equals to log of uh, log of x to the power of y. Okay, it's saying false, but it's still correct, right? It's correct there. So let's define any particular term. Let us import a, b, c, d, e, f, g, h, I, j, k, l, all will be there. And let us also take a, b, c, d, e, f, g, h, I, j, k, and l. A, B, C, D, E, F, G, H, I, J, K, L. There is a syntax error where. Alright. This one. Fine. So still it is saying like that. No problem. Let's take A. Let's take A. Okay. So this is a rule particularly that a into log of x is equals to this is here, that is x to the power of a. Okay, only if the x is positive. and only if the a is a real number, right? So we'll see that one. Don't this is a rule. Okay, this is a kind of a rule. Similarly, it is also a rule that log of a x and a log, not log of an x and log of a y is equals to what? Log of x multiplied by y. So if only if the x and y are both equal and should have any values, okay, both are positive, so we'll just combine it like that. So since we haven't give any of the values, so it would be a bit false, right? It would be obviously false there. Yeah, that's all right. So logs combine will just take the logarithmic values and will combine them using these rules, these two of the rules, right? So let's take its kind of uh, right, logs of combine and a into the log of x, and let me define x as x only. Otherwise, I will be writing x and it will be coming p log of y. Okay, so let's just combine these things. Z is not defined. All right. Okay. So it's a log p. Again, x is coming p. So do one thing, guys. Just let's write here I, j, and k. These and don't have any values. So you can see if I just combine all the things of the log, you can see it's kind of an a log I plus log j minus log k, right? So if force parameter of this function is said to be true, then the assumptions of this particular you can say expression is kind of an quantity, right? How let's write it as force equals to true, and it also says what is here. So force equals to false, and this particularly takes or combines them using the following rules. So these are the rules that log x plus log y equals to log of x plus y if both are positive, and a into log x equals to this if x is positive. So and if force is true, then the assumptions will be of the above will be assumed to hold if there is no assumption already present, and so on. For example, if a is an imaginary or the argument negative, force will not perform a combination, but okay, but if a is a symbol with no assumptions, the change will take place. For example, it is giving some of the values over here. We'll just try to, you can just go on with these things. So how you get to see these things, you just press shift plus your tab and you will see your answers. All right, so let's run this and we'll see like that. Exactly correct. Okay, so these are some of the logarithmic functions, right? So now let's come to the differentiation part, guys. All right, so I think we should come with the differentiation now, derivatives and all those things. So let's see some of the derivatives now. So the derivative of a function, you know, right? It's the instantaneous rate of change, particularly with respect to some of the any kind of variables, right? For dt, dx, dy, anything, right? So that is defined using the def function. It is defined using the def. That is a differentiation, right? So you need to write the first expression. You need to differentiate with respect to some of the variables. You need to differentiate. Okay. Let me bring my class 12 book. Where is my mathematics? Differentiation. All right. So I got it.
Sir, what is the use of force? Force equal to 2.
You can see here. Just read it down. See. Till then, let me find a question for you. Yes, we'll start with the basic differentiation. Differential calculus. Differential equations. Differential equations. Yes. So let's start with these things. Okay. So first what I said is you need to define some expressions and then you need to define some of the variables. Right? So we'll do it. Let's now just I have imported everything. Let's also import. This is right that my expression is x multiplied, let it be I multiplied by the sine of I, and this is plus 1. So you can write, see I is equals to, or you can see it's I sine x I square, sorry, I into sine I square plus 1, that's all, right? So this is my expression particularly, and let's print the I. So this is I into sine I square plus 1, right? So if I want the expression to be differentiated, I want this to be differentiated, guys. How will you differentiate this? Or with respect to the I, if I need to differentiate it, what is the value? Yes, differentiate, basic mathematics, value is weighting. So see the expression, where it has gone. The expression is I sine I square plus 1. So if I this differentiate it, what is the equation? 2y square cos square I plus sine I square. Okay, so this is the power of SymPy. You don't need to write. Okay, suppose now if I write is kind of differentiate the expression, whatever the expression is, I'll based on the exponents too. So if the exponent differentiation we do kind of I square, sorry, I square on the you can say with respect to the I. So that is 2I e I2 square, right? Exactly. So suppose to take multiple derivatives, you just pass on the various variables, how much you want, right? Kind of, let's say for differentiation of the x to the power of 4, we have not specified x, right? So it's I to the power of 4 and write it with the I and with the 3. So with respect to constant, it will give you 0 exactly. You'll be just be getting 24i, right? So these are the things you just imply in your codes for differentiation, right? For these are the things, just basic things, right? So let us take questions. Before questions, let's go some of the more factors. Let's say I have j multiplied by sine of j, and let it be sine of j into j. Then I take its plus 1, and that is I want a differentiation of this. So this is my equation. I want to differentiate this. So I'll be getting 2j square cos j square plus sin j square, isn't it? Right? Right? So you don't need to just go for methods for differentiating, right, guys? Don't need to understand the mathematics also. Just you just know the technique how to differentiate. That's okay. And now you don't need to differentiate these things. Right? These are just all the common things. So similarly, you just can also get the derivative. So if you write the derivative of this particular equation, let it be y. No, let it be h. Okay, we haven't. I think we have imported h2. Yes. So let it be h. So derivative of h would be dy dj, and with respect to j, right? Exactly like this. Okay. So this is similar. Right, so you can see. Mhm. So any confusions in the derivative part? This is how you just get to see the derivations or just the derivatives. Similarly, you also have the integrate to work on. If I see it, if you just see it there, so this is kind of a derivative, and it says you can just everything that requires arithmetic operations to define there, right? Okay. Similarly, we have integration, and in integration we write integrate the function and then the x, whatever you want, and you just got it to integrate there. So to compute a definite integral, you just pass the argument kind of integral integration variable, lower limit and the upper limit, right? So for that, just take it as x and y. Again, that will be symbols. All right. So these are the x and y. So let's take the expression again. Now let's say the expression is x square plus x plus 1. So you need to integrate this equation. If you see your ex, so this is x square plus x plus 1. Now if I need to integrate this, what I'll do? Yes, the integration of this equation would be, yes guys, answer there, integration there. Do the integration quickly.
X cube by 3 plus x square by 2 plus x.
Correct. So for integrating this, what I'll do, just I'll pass the function, this is my expression, and with respect to the x I want to integrate. So I'll get the answer that x cubed by 3 plus x square plus 2 plus x. So this is the speed and this is the power of how you can just work with the libraries of these things. Okay. Suppose you have an expression. Let's say you have sine of x and you have multiplied it by the tan of x. So exactly what you have, if you have sine of x, that is sine square x by cos x, right? So you see it by x equals to your sine x tan x, exactly. If I see it kind of integration, and if just I take it as tan x is equals to sine x upon cos x, right? So that is sine square x divided by the cos x. Okay, so we can integrate this too. That is, if we want to integrate, we'll write it as integrate the equation of ex. So what is the equation there? Integration of that, minus log sin x minus 1, then all these things, right? Exactly. Correct, guys? Now you seems to be sir is doing mathematics now. So that is important, right? Because in the data science, you will be dealing with the data there. You need to just do some calculations, right? The AI ML guys, you will be just predicting your models. So there you'll be used to do some mathematics. And isn't it interesting to do mathematics with your keyboards instead of doing these things in the copy? Right? It seems to be interesting or not? Yeah, I just expect some answers from here. Yes, is it interesting or like kind of just a bouncing terms or a bouncer going there? Yes, interesting. Moms is saying interesting. All right, yeah, I feel it interesting. What about these guys? Arijit's, Mispa, Supriya, Pooja, Pushpa, Nusha, Harita. I think it will be interesting for you all, right? Because still, if you are not from a background of mathematics, you can operate the mathematics things. Just you have to go with a very simple definition. What is this? Okay, this do with these things. So the only thing is class 11s to be brushed up. Not exactly. You don't go for the reading of the books and all these things. For any, if the function is not understand to you, just click Shift and Tab, and you will be getting to all the things that based on the algebraic classification, all this, right? So most of the time, if the student is not from a background of mathematics, so that is a very bit it would be hard for him to understand. But if he goes with the just the basic definitions or help from all these, he'll be able to understand everything there. Okay, so yes, that's easy. Moving ahead, so let's say let's just take off that you have an expression that is equals to let's take. So now see guys, if you just pass on the definite integral, now if you just have a definite integral, so definite integral you have to pass exp there, and then you have to write your definite integral, and then let's say integrate the expression. And then you give your parameters there, x0 to the infinite value, right? Now infinity is something this you might understand, I think. So integration of this will give you under root of y by 2, right? So you can pass multiple limit up to the tuples of kind of the multiple integrations, right? So there, let's say that you have all these, just copy it there. Or let's give it, so that's pi by 4. Okay, so you can pass on the values. So now you can create unevaluated integral using the integral object, or which can be just so if you want the unevaluated integral, you can just do it by the function of do it. Okay, do it. So that is in function for that. Okay, so let's take that you want an integral of an equation. Let's say it's log of x squared and this x. So integral of this is integral of log of x square dx, right? So this is can be done also if you just pass on here. So if you just pass on here, it's like for the exp dot your do it. So what does this particularly perform the integration using this, you can write of the C what it does is kind of the things you will be getting always, right? So this will be giving you an unevaluated integral. So this is x log x square minus 2x log x plus all these things, right? So there are in the college, I think you might have read the type of integrals, that is kind of Laplace transform, Fourier transform, sine transfer, cosine transfer, Hankel transform, and might be much more. Anyone who read all these things in the college, might you have read it? Fourier transform you might have read.
But Fourier transform we have studied.
Alright, Laplace transform, anyone? Me. Surya.
Yes, sir.
Sine transform, cosine transform, Hankel transform. You might have done. Okay, if you don't have done, no problem. You can see here, right? So if we do it as an integration kind of, let's take an expression. Let it be an expression as your. So I think in which year this is there around second, third, fourth year. There would become some kind of that. I've studied in the class 12th. So expression is kind now having a definite one, right? So just giving it there. And we want our Fourier transform. And we will be giving our expressions with respect to the x and the k. Yes, we have imported k. I think yes. So we see the Fourier integral object is not callable. Where? All right. So this will give you the integral of that. Right? That is your square root of multiplication by the e to the power of pi square x square. Right. So you can also write this as kind of sqrt, and sorry, this is sqrt of your pi, and then you can just pass on this, that is an exponentiation of your minus pi into 2 into the k, and that is square. So you'll get the same value, right? So these are the things you can just write. So similarly for the Laplace transform, you just have to write it as now let's just take Laplace transform. And just do an equation. Let's say k. So this will be particularly giving these outputs as kind of, but still there is some problems there. Laplace is doing it. All right, we'll see Laplace later. There might be some problems, so we'll see. So let's sum up with these things. Where's my charger? It's 49%. Still okay. So we'll see now the matrix, how to make a matrix, how to work with matrix, right? We have seen matrix, read matrix in class 11th, I think, class 10th also. Yeah, deals with the matrix. The matrix are like just a very easy thing to write on. You just keep the beginning kind and then the ending kind of a matrix, like kind of what you write, that let it be a matrix. So this is a matrix, and just 2 comma 3, and or just you pass these things, will run in the numpy there, 1 2 3, and then dimensions, dimensions 2 3 1. It's n dimension, 2 dimension. The number of brackets you see is the number of dimensions in this code. Alright. So when I was understanding it, it was quite a very tough thing to make me understand. I was just so seeing that it was just going on, and then the brackets and brackets. What are these brackets going on there? So I just come up with a very sum of that. The number of brackets I'll be seeing in the front one, that is the number of dimensions I have. Okay. So that was a quite good thing I saw. So if you run your AM, you will be getting a matrix. That is a particularly your 2 cross 3 matrix, 2 rows and 3 columns. But you can see that, right? Similarly, you can make a 3 cross 3, 4 cross 4, any kind of matrix. So if you say a matrix, an identity matrix, let's say, no. So let's 1 comma 2. How an identity matrix looks like, guys? So a null matrix would be that would be a kind of a null matrix, you can say, right? So it's now 2 cross 4 1, right? You can define it on number of ways you want. You can define it like, so it depends on you what type of matrix you want. There is some problems here. So these are the things. Now it depends on you. And if for any matrix, if you want to see its shape, so you can just shape it that it is having 4 rows and 2 columns. That is your 4 rows, 2 columns, basic things, right? You can see the shape, you can see the rows, what are the rows. So let's give a name to this. Let's say I'm having M, so M is basically this one. So what is the M dot shape? This is this. Similarly, if I want to see the row, so M dot row of, let's say I wanted the first row, so M dot row of first row. The first row is 1 2 3 exactly, right? So these are the things. If I want to access the column, so the column of the first column or second column, so second column is this one, 2 1 3. So this is my second column, right? This is the first column. This is my first column, that is 2 and 3. This is my first column, this is my second column, 2 and 3, right? So similarly, you have a lot of things. Let's say you want M dot row, and you said that you want from 1 to 3. So sorry, you want a row of 0, and there you pass it from 1 to 3. So you can get the numbers. So what you did is, from the M of 0, you just pass from 1 to 3. That is from 1, that is from 2, and 2 till 3. So there are only 2 elements, so you'll be getting there. So it's just kind of an indexing you are doing in your 0th row, right? Understood? So these are the basic things you just do with the matrices, right? So similarly, matrix has an operations to insert something or to decrypt something. Let's say we have M2, and it is a kind of a matrix. So there you have a matrix, and you write it as matrix of, let's say, 40, 5. So if you see M2, that is a matrix of 40, 5, right? Now, if you want to insert a column, you write it as M dot insert, let's say 2, M2. Alright, so if you see your M, you can see now that is your M was particularly previously, your M was 1 2 2 3 3 1. So it became 1 2 2 3 and 3 1 there, and it comes with a 40 and 5. So what exactly is 45? That is your M2. So inserted M2 column inside the M column. So these are the things you can just go on, and you can just add on the matrix to, let's say you have a matrix 1, and it is a kind of matrix with probably 1 2 3, and then it is 4 5 6. Similarly, you have M2, let it be matrix of 4 5 6 and 1 2 3. So you have like this, okay? So now if you see your M1, it will be a kind of matrix 1 2 3 4 5 6. Your M2 would be 4 5 6 and 1 2 3, right? Now to add up all these, what we'll do is M1 plus M2. So this is probably 579 and 579, exactly the same, right? So you'll be getting like that. You can meanwhile just solve on M1 multiplied by M2, comma M1 minus of M2. So 2 3 matrix size mismatch. Why? Okay, let's do it. Let's take a M3 and make it alright. So now M1 multiplied by M3. Okay, this is M1 multiplied by M3. Similarly, M1 minus of M2. So okay, give it one by one. So m1 multiplied by m3, m2 minus m3. Okay, this would be a shape error. That's fine. M3, m2 minus m1 can be done. So you'll be getting these values. So similarly, there are a lot of things to work on. You can just give the value of determinant. So to calculate the determinant, you will be using DET to calculate the determinant, right? So what is exactly a determinant, guys? Let's say we are having a C as your matrix, and let's write the password 10, 20, let's see, comma. It can be any particular value, right guys? 30, 5, 6, 7, 8, 12, 34, 56, 23, any particular values, 15, and such. Okay, these are your, if you see invalid syntax there, okay. So list length should be equal to rows and columns. Alright, let's give some less columns there. 8, 12, 9, 6, 15, like that. So this is your 3 cross 3. So you have 10, 20, 30, 5, 8, 12 and 9, 16, 15. That is 3 cross 3 columns I have defined, and then I have given the values of 3 cross 3 column, right? Now to find the determinant, that is your C dot DET. So determinant is minus 120. This is how you can just get it out. Understood? Similarly, we have an kind of zero matrix or one matrix, and also the identity matrix as my i's. You can we say I as the identity matrix. In the NumPy, we'll see all these things, right? So let's come with those. So let's go with the I1. So let's take, we have a matrix 1, MRATIS matrix, and let's just pass on the values. Let's take it as 1, 0, 0. Similarly, let's take another one, 6, 0, 1, 0. Okay, now you have some these things to carry on. So we're gonna run. This is your identity matrix here, exactly, right? So these are the identity one, right? So you can just also see the diagonal initialized in a diagonal matrix, right? You know diagonal matrix. What are these things? So you will have this type. So you'll be getting a diagonal matrix of 1, 2, 3. Whatever you write, you will be getting a diagonal type of thing, right? You can also get your zeros. What are the zero matrix, guys? You remember, right? So zeros, if I write 2 cross 3, so I'll be getting a zero matrix of 2 cross 3 column. Similarly, if I write ones of some 10 cross 10, so I'll get a 1 cross matrix, just a 1 matrix of 10 cross 10. It depends on what I write. So similarly, you have I also. So for I, you have seen the identity matrix. Write I of 3. So you'll be getting I of 3. If you write I of, let's say, 5. So you'll be getting an I of 5. It is an identity matrix of 5 particular, right? So these are the things which we work on to just get the values. This is how we just find everything. Understood? So I think now these are the, right. For the complex numbers, kind of we use the SymPy for the kind of a function class. Okay, so we use the ray functions RE. Okay, so RE is the real part for that, right? So let's take a function and just take an you can say for the complex number, I want a real part of the function. Let's say it's 5 multiplied by or let's say it is 5 plus 3i, so 3j, let's say. So 3rej plus 5. That says that you are having the real your part as your 5 and all these things, right? So if you want the real part of j, that is your rej. So let's write with the sum of the terminals. Let's write it as from SymPy and there we have a standard is I. So we'll be getting 5 out there. That is real part is your 5, right? So if you write the real part, so if the imaginary part will be 0. So the imaginary part is just given by the IM. That is your, you can say it's LM. So that is stands for your imaginary part, or you can say it's IM. That is that's cool. So many times you will be seeing it like LM. That is not LM exactly, your IM. Okay. So this will be giving you the imaginary part in place of remember we did for z dot real z dot imag. So here we can just find out like this. So this is the imaginary part. Okay, so if you write an imaginary of I and the real of I, you'll be getting the values. The imaginary sign object is not callable. Very good. The real of I. So imaginary is kind of a 1 and 0 is giving there. So if you just remove these things and let's see the imaginary of I and the real of I. So what is the value of exactly the I? So imaginary of I is always 1 and the real is always 0 kind of things. Okay. So you get sign 1. For the real expression, 1 is said to be positive, minus 1 negative, and 0 say that it is equals for those. Okay. So the sign function, what I will be using now, will return the complex sign of the expression. So if I write it as a sign, and if I write it as 1.55, comma the sign of minus 1 and the sign of, let's say, s dot 0. So if I write it like that, so 0 was not instituted. Let it be 0, 1. So you get it 1, minus 1 and 0 there. Okay. So a positive will give you a positive 1 and the negative will give you negative 1. So this is the function that returns you the complex sign of a expression, right? Similarly, there is a function abs. Okay, you have abs function there to return the absolute value of a complex number, right? So let's say you have an function called as abs and you want the absolute value of that. So u2 plus 3 multiplied by I. So that will give the absolute value is root 30. Similarly, you can also get the conjugate. So what conjugate does? It returns to the conjugate of that. You can write 5 plus 4 I. So this will give you the conjugate of that one. Okay. Similarly, you have the all the things required for your trigonometric functions. As I said, if you write a trigonometric function there as a kind of, if you want a sine pi by 2 value, so that is exactly 1. That is sine 90. Similarly, you can write the cos 90. So it's 1 and 0. Similarly, you can just write down the tan of pi by 6, which is reduced to square root of 3 by 3. Alright, so you can perform on various things by using this. Similarly, you have the sine of that. So let's say a sine of 1, and let's say a cos of the square root of 2 by 2. And also let's take a tan and the square root of 3 by 3. That will give you the value that pi by 2, and pi by 3. Alright, 6, sorry, it's pi by 4 and pi by 6 there. Okay. Similarly, you have ceiling as an unvariate functions when you deal with one particular one particular number, it's called as kind of an unvariate, and more than one we'll be calling it the bivariate. So we'll be doing this in machine learning as an unvariate data and bivariate data there. Okay. So ceiling will give you the this unvariate function which returns the smallest integer value but not less than the argument. That is exactly the what you have written in the math, where is math dot seed, remember. So similarly we'll be doing that one. So that is ceiling. This function is very much similar to that. That is ceiling of 5 will give you the 4. Alright. And ceiling, you can just check it on how it works. So it is an unvariate function which returns the smallest integer value not less than the argument. Okay, so this implementation generalized ceiling to the complex number is now this. So from SymPy EIS wrote rational, ceiling of 17 is 17, rational number of 23 by 10 is 3, 2 into E is 6, and all these things are there. Alright, you can just go on with these things for the mathematical terms. Similarly, if you want to just find out the fractions of something, let's say you are saying a fraction of 3.99, and you will be getting a fraction of that, right? So this represent the fractional part of every particular thing. Suppose you want a fraction and in a rational form. So you want a fraction in the rational form, so you'll be writing as 10 comma 3, and then you run it, so you'll get it's 1 by 3. Yes. Alright, these are the things you'll be getting on there, right? A fraction of just a 10, let's say a fraction of 10. So this function represents the fractional part of whatever you write. So this is the things. Similarly, we have seen the factorial and everything, so we're not right to go to the factorial functions now. So if you want, still I'll go into the factorial one, right? For the factorial of 5 is 120. Similarly, factorial of minus 1 is kind of minus kind of an infinite value will be getting on. Okay, so similarly binomial and all these things have been done. So there are some Fibonacci series. So Fibonacci series are the numbers of the sequence divided by the initial terms, and for that you just write for the Fibonacci of any particular number, and then you write for x in integers, or let it be for x in a range of. So you define a range of 10 numbers and you want to see the Fibonacci of that. So run that. So you'll be seeing 0, 1, 2, 3, 5, 8. So understood what is Fibonacci is like, right? I think you might know how is Fibonacci is. First two numbers are same, and then you just keep on 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, and 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21, and 21 plus these are the just stuff. Okay. Similarly, you have Fibonacci also. So what Fibonacci numbers are the integer sequence divided by the terms of the 3-term recurrence, right? In the Fibonacci you have 2-term recurrence. In the Fibonacci you have 3 terms of reference. Similarly, let's say you give the Fibonacci of 5 and you just pass it with the x. So you'll be getting x to the a3x by 5 and x. Okay. So that you will be able to understand. Will not go in all these much because these are not much very important for you all. Okay. These are just as a kind of just an information, so I'm giving you there. Okay. So similarly, if you want to find the minimum number from anything, let's say you want a minimum of from your pi and with respect to e, right? So that will give you the e. Similarly, you want the maximum value from 5 and the rational you are giving 11 by 2. So you'll get is 11 by 2. So these are the things you can just find out. If you want a root, so root of 7 and then the rational of 1 by 2. So it's 7 and that is a root particularly. So if you find the 7 square, you find 49, right? So these are the things. So now this is similar. Square root of 5 will give you square root of 5. These are the things we did in the very basic thing yesterday. Square root of just a, you can say, uh, what to say this, as a kind of a perfect square, right? So for perfect square you will be getting a square out, right? And for these things you will be getting a under root of all that. So these are the things which are coming inside your uh, kind of SymPy, right? So these are the things, and we just sum up with all these things now to just come up in the end. Now we have read what are the things we have read. We have read the how to go about the symbolic computations. We have seen everything there, right? Similarly, we also have some plottings which we can do using the matplotlib and all these things, right? So matplotlib plottings will be doing on later, but also you can just plot on things with the uses of SymPy module. You just plot the things the 2D and 3D plottings. So we'll have that too also. Like you just give the things of plot. It's like you just write the plot and then you write the expressions and all those things. So now let's say you want to plot x square and uh, you want to plot the x square. So it will be just plotted out there. It is x square, right? So now my x would I have defined x there. Now if you want to just give a color to that, we'll have another session for this. Don't worry. So if you have just a light color, you just let it give it any of the color. So I'm giving it red, so I will give a red plotting out for that, right? Similarly, we can just pass out the sine graph and cos graph for that. If you write a plot and then just write the sine graph to be plotted out and the cos graph also to be plotted out there, and on the basis of your data as x, just give your range there. So it's minus pi to pi. Okay, so you just want to plot these things on the basis of all these. So you'll be getting a plotting out there. These are the basic things, right? We'll be discussing all those things by later onwards. So you can also get a 3D plotting. Let me show you how to get a 3D plotting. So you for 3D plotting, just import. Let's say my x and y are the symbols, and these are x and y. All right. So these are my symbols, and I just want a 3D plotting of x multiplied by y. All right, and I give my parameters to be x minus 10 and 10. Similarly, for the y, I'll be giving it as y minus 10 and 10. That's it. So these are my parameters of x and y, and I need to just to plot these things. Very basic, you will be getting a 3D plotting out there. So these are your parameters. All right, we'll discuss on later one. All right. Okay. So these are the things. Let me just cut it there.